Alright, so here we have two identical carts. Alright, so we have a cart that has a mass of 1.5 kilograms that's moving 6 meters per second for this situation, and we have a cart over here with the same mass and the same velocity moving to the right as well. Alright, the left car hits a spring while the right car just hits a wall. So calculate the initial momentum of the carts. Well, it's going to be the mass, which is 1.5 for both of them, times the velocity, which is 6 meters per second for both of them. So they're both going to have the same momentum. Momentum is equal to mass times velocity, which is equal to 1.5 times 6. So we multiply 1.5 and 6. And we get 9. So it's 9 kilogram meters per second. Alright, calculate the change of momentum of the carts. Well, before we have 9 kilogram meters per second. Afterwards, it hits the spring or it hits the wall, and now it has 0 meters per second for both situations. So we go from having 9 kilogram meters per second to having 0 kilogram meters per second. So our change of momentum is negative 9 kilogram meters per second. Alright, remember, change of momentum is synonymous with our impulse. Impulse is our change in momentum. So we have an impulse of negative 9 kilogram meters per second. So remember, we have our momentum before plus or minus impulse equals our momentum afterwards. Well, this has to be negative 9 in order for this plus this to equal 0. Alright, moving on. C. Which cart experienced the bigger change of momentum? Well, they both experienced negative 9 kilogram meters per second change of momentum, so it's the same. Okay. Which cart felt the bigger impulse? Well, change of momentum is the same as impulse. Our impulse was negative 9 for both, so these are going to be the same. Alright, I know that there is an inclination to pick the right side, that this car stops a lot faster, and so the impulse or the change of momentum would somehow be greater, but it's not. We still have the same amount of momentum before and the same amount of momentum afterwards for both situations. So our change is going to be the same. Okay, but which cart felt the bigger force? Well, impulse is equal to force times time. So if you have a smaller time, you have to have a bigger force. So out of these two, the spring took 0.5 seconds to stop, the wall took 0.1 seconds to stop. So this has a smaller time, so cart 2 is going to have the bigger force. Alright, calculate the force on each cart. So force, let's see, we have an impulse of negative 9. Impulse is force times time. Therefore, if we wanted to solve for force, we could divide both sides by time. Okay, so our impulse was negative 9, and our time for this cart 1, so we can say for 1, is 0.5 seconds. And when we divide that out, negative 9 divided by 0.5 is negative 18. So we end up with negative 18 newtons for this cart on the left side, cart 1. And for cart 2, we have the same impulse, negative 9, but instead of 0.5 seconds, it only took 0.1 seconds. So we divide by 0.1. So negative 9 divided by 0.1 is 90, negative 90 newtons. So because the car that hit the wall much faster, the time is smaller, the force has to be greater. Alright, so to give the same change of momentum, you have two choices. You can increase force, decrease time, or you can increase time, decrease force to get the same momentum.